Okay, so let's talk about um, converting two complements hex to decimal. I actually added this table. Um, so the first thing I want to tell you is how to know if a hex number is positive or negative. So if you look at our um, binary number, we said that we look at the most significant bit. So if we had 1, 0, 1, 0, we look at the leftmost bit, this 1, and we see it's a 1, so that's a negative number. So that's how we know in binary. But what about hex? Because in hex we have like A, B, C, for example. So how do you know if this number is positive or negative? So the way is that you have to convert the leftmost digit to binary first, and then from the binary we can know. So if you look at this one, for example, this A gonna be 1010, and then B gonna be something, C gonna be something, but it doesn't matter. We are looking for this one here, and that is gonna be a 1, so it's a negative number. So this is a negative number. And if you look at this table, you see from 0 to 7, all of these are starting with 0. But then from 8 to F, they're all starting with 1. So then as a rule, if your hex number start with 8, 9, A, B, C, all the way through F, then you're dealing with a negative number. So that's the first thing to know here. The rest of the rules are the same. The only difference is that when you want to flip the hex number, so when we had a binary, it was easy. So we had 0, 1, 0, 1, for example. You want to flip this, it's very easy. Okay, 1, 0, 1, 0. You changed all the bits. But if you have a hex number, so if you have that ABC here, how do you flip this? You cannot like put A something else because it's difficult to know what it's gonna be just looking at the digits. So the trick to that is to subtract everything from a digit F. So what you're gonna do, you're gonna put F, 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 so same amount that you have, and then A, B, C, and then you subtract this one. So from C to F, that's basically you have 1, 2, 3. So it is gonna be 3. There is gonna be 4. There is gonna be 5. So this is gonna be your flip number. And if you actually do it, you're gonna see that you're gonna get the same number. And that is in hex, of course. So why does this work? Because if you look at this one, for example, this 0101, that is actually flipping the number. If you do 1, 1, 1, 1. So F, by the way, it's 4 ones, right? So we are subtracting from all ones. So if you have this one and then you do 0, 1, 0, 1, whenever you have a 1, you're gonna get a 0. So I had a 1, I'm gonna get a 0. So it did flip. Nice. If I had a 1, if I had a 0, I'm gonna get a 1. So yeah, I had a 1, I'm gonna get a 0. I have a 0 here, I'm gonna get a 1. So actually doing this gonna flip the number. And what is that in hex? That is F. So that is the only difference that we have here. The rest of um, the steps is the same. So we subtract from F, add 1, get the decimal value of that, and then put the negative sign back. So here we have the converting the other way, so decimal to hex. So if it was a positive, so for example, decimal, I'm talking about basically normal numbers, right? If I have like 18, if it's positive, we just convert it to x, and no worries for the sign. The only thing we have to know is that the most significant should be basically 0 to 7 because it's a positive number. If not, we can add a 0 if the bits allow. If it's a negative, it's again the same thing. First we convert, then we calculate the two complements of that number. And two complements of the hex gonna be you subtract everything from F because that's gonna be the basically flipping step, and then you add 1. So basically, same thing. It's just like in hex. So here we have the example. We have minus 73, and first we calculate the 73 in hex. So when you calculate 73, you're gonna get 49. So that's your hex number. And then how to do the two complements now? We subtract that from f, we get this number, plus 1, we get that. So this is going to be our two complement representation of minus 73 in hex. So this one is positive 73, and it is negative 73. And that's it for the hex number. No trick. The only trick is the f's that you have to subtract. Adding the number is the same, and the sign gonna take care of itself. Subtraction is again the same. So if we have the negative number here or subtraction here, we're gonna switch that to positive. And the way we do that, so we are basically switching our subtraction to addition. We calculate two complements of this. So how do we do that? 1, 2 gonna be, and this is the TC here is two complements. So we minus that from F's, and we're gonna get this, then we plus 1, we're gonna get this number. And then we add them basically. And the adding is here. AB plus EE. So we get 9 plus 1. So that was B is 11, E is 15. We got 25. And we said, how do we know what is the number here? We have to minus 16. So we get 9. And the carry is always 1 if we have two letters here. The same thing we do here. There's a carry, and we basically ignore the carry. And we have to look, anytime you do a two complement addition or subtraction, you always have to look at the final sign of your number. So did we expect a negative or positive here? So this is a negative number. I'm saying that because it's a, and that's a start with a 1. So there is a negative number, and we are subtracting a positive number from a negative number. So it's saying something like, for example, minus 20 minus, there is a positive number, like 5. So what is the answer here? You have negative and then subtracting something from a negative number. So it should be negative. And we did get a negative number. 9 started with 1. So that's not an overflow. If it's an overflow, it's okay. You just have to indicate, for example, if it's on a test or homework or anything, or even on like computer when you're programming, you just indicate that there was overflow.